In this video, we're going to talk about when our straight chain alkanes loop back around and connect, forming a ring. Previously, we've learned how to name a 3-carbon chain would be a propane, a 4-carbon would be a butane, 5 would be a pentane, 6 would be a hexane. These all have single bonds, so they have the A-N-E ending. But sometimes in organic chemistry, these carbon chains can loop back around, forming a ring. And as you can see in this first structure up here, you have 3 carbons connected in a circle, and so when you have them looped back around, you add you add a prefix called cyclo. So the only change in the naming structure would be that you pick out the longest continuous chain, you count how many carbons there are, and if it's a ring structure, you use the regular carbon numbered name. You call it A and E for the single carbons, and then you put the cyclo in the front, so cyclopentane. The naming scheme in general is pretty simple until you throw some branches on. Branches aren't any harder, you just have to think about when you're counting them. You are given the option of counting in a clockwise or a counterclockwise motion around the chain, and you always start with 1 at the first branch. So it's always assumed that if you have a methyl attached, it's going to be at carbon 1. You would just begin numbering there. Then you number the rest of the carbons in the chain to have the lowest numbers available. You would number this one up here, 1, 2, 3, 4, 5, 6. So this a 6-carbon chain would be a cyclohexane. And now, because we've numbered, we have groups on the carbon 1 and carbon 2. We have dimethyl, and it's a 1,2-dimethyl cyclohexane. Looking at this number 2 example here, we have a 3-carbon chain, so that's prop. So it's propane, because they're all single carbons. It's a cyclopropane, because it's in a ring. And on our carbon 1, we have this branch. It's a 3-carbon branch, and we're attached in the middle. So a 3-carbon branch would be a propyl, and because it's in the middle, it would be isopropyl. Now, we do not need to say that this is on carbon 1 because it's assumed to be on carbon 1, so that would be isopropyl cyclopropane. Looking at example 3, we have a 5-carbon chain, so that's going to be a cyclopentane. And we have we have a branch on 1, 2, 3 spots, so we would number this 1, 2, 3. So we'd have a 1, 2, 3 trimethyl cyclopentane. Okay, so this would all be one word here. I just ran out of space, and it's kind of hard to write with a stylus. Here are some additional examples you can look at. I want to draw our attention to, let's look at letter E and letter F. In letter E, we have a 4-carbon chain, so that would be a cyclobutane. And we have, we can number it with a 1 over here or on the opposite side. So 1, 2, 3. We would have a 1, 3 dimethyl cyclobutane. Now, so far, everything we've numbered has been clockwise as opposed to counterclockwise. I wanted to show you this example, letter F here. If we start numbering here at this position with a 1, 2, 3, 4, or we could number in the reverse direction with a 1, 2, 3, 4, 5. Which is going to be the better choice, the blue or the green? Well, the blue is because the numbers are going to be lower. So in that example, you have a 1, 4 situation that would get you better branch numbers. Some people would argue that it would be better to number 1, 2, 3, 4 going in that direction. Typically, this group up here is an ethyl group, whereas this is a methyl group. So ethyl comes alphabetically before methyl, so most people will call this carbon number 1. So they would go with the blue scheme working their way down.